this is a exponent rules of exponent type of problem. And there's several rules of exponents. Well, there's a lot of different rules, but there's three main ones. All right. Let's see. Rule number 1 says, if you have x raised to the a power and you multiply that times x raised to the b power, that means it's going to be x to the a plus b. So, for example, if I had x to the second times x to the third, that would be x to the 2 plus 3 is 5. And the reason that you add is because x squared is really an x times an x. X cubed is an x times an x times an x. And I am multiplying all that together. So I'm really multiplying x times x times x times x times x, which is just repeating the multiplication of x 5 times. It really is a multiplication problem because I'm taking x squared times x cubed, but the trick is just add the exponents. Okay, so that's rule number 1. Rule number 2 says if you have x to the a divided by x to the b, then that is equal to x to the a minus b. So if I have x to the 5th divided by x to the 2nd, that's going to be x to the, and it's always the numerator's exponent minus the denominator, so it would be 5 minus 2, not 2 minus 5. So that would be x to the 3rd. Now this really is a division problem, but when you take x to the 5th, that's x times x times x times x times x divided by x times x. And then what happens is those x cancels and those x's cancel, and you're just left with x times x times x, which is x cubed. So the shortcut is subtract the x's. 5 minus 2 is 3. It's like these two x's here cancel out 2 of the 5 up here, leaving you with 3. And then there's rule number 3, which is the power to the power rule. So if you have x to the a in parentheses and you immediately raise that to another power, power to a power, more power to you. You're going to multiply. So this would be a times b. So if I had that x squared and I cubed it, that is really just x to the 2 times 3 is 6. The reason you multiply is what x squared cubed, what this really means is an x squared times another x squared times another x squared. If you cube something, you take it times itself 3 times. And then what I have is x squared times x squared times x squared. So I would add my exponents. 2 and 2 is 4 and 2 more is 6, right? Because you're at this point right here, you're back to this rule where you add your exponents. And 2 plus 2 plus 2 is 6. Of course, what I just did was add 2 3 times, which is how multiplication was invented, was simply repeated multiplication, or repeated multiplication. You would just add them together. And then actually there is one more rule I want to go over with you. Don't really have another good color here. I just used the purple. I guess I'll use the purple again. Or wait, darker purple. Oh, how about orange? And rule number 4 basically says if you have x to the negative a power, that's the same as 1 over x to the positive a. Or if you have 1 over x to the negative a, that is the same as x to the positive a. It takes me a little longer to explain why that is the way it is, so I'm just going to ask you to accept it and move on. Basically, when you flip it to its reciprocal, the negative exponent becomes positive. And depending on how you work your problem out, the thing about the exponent rules is there is no rule about which rule to use first. There really isn't. So depending on how you work the problem, you know, there's more than one way to skin a cat. Not that I've ever skinned a cat, but that's just something my daddy used to say. Okay, so looking at this problem, the first thing I happen to notice is these parentheses, and they just kind of pop out at me. So, and my brain is already programmed that when I see parentheses, it's like, do me first, you know, that whole PEMDAS thing. So I'm actually going to take my MA to the 4th and square it. That would be rule number 3, the power to the power rule. And I also have to remember that what I really have here is an M to the 1st, A to the 4th squared. So the M is going to be a 1 times a 2, and that's going to be a 2. And then the A is going to be a 4 times a 2, which would give me an 8 right here. So that's that part. But I still have the times 1 over M to the 6th, A to the 2nd. And you can really, if you want, you can put this like over 1 if you want, like that. And now what I'm looking at is like just like a fraction, you know, numerator times numerator, denominator times denominator. So I'm looking at M squared A to the 8th over M to the 6th, A to the 2nd. And then I'm going to use that second rule, which says subtract the exponents. So for my m's, I'm going to have m to the, you're going to take 2 minus 6, 2 minus 6. And then for the a's, you're going to have a to the 8 minus 2. So what I've got is m to the negative 4th and a to the positive 6th. But I'm pretty sure, let me see, I should say don't simplify the given expression, write your answer with positive exponents. So I'm not allowed to leave that negative exponent in there. So I am going to have to flip this to its reciprocal, which will be 1 over m to the 4th times a to the 6th. And then just to make it look pretty, this is like a to the 6th over 1. It would be a to the 6th over m to the 4th. So I'm going to go back into Mobius. I'm going to click on this, and this is one, will it let me? No, doesn't give me any of that. Let's see. Okay. I've forgotten already. What was it? A to the 6th over m to the 4th. So a raised to the 6th over m raised to the 4th. It didn't give me a thingy here. Let's see. How did I do? Is it going to accept it? Yep, it accepted it with the little carrots for my exponents. I got these little carrots, these little carrot things here, that symbol there. That is on my keyboard. It is right underneath the number 6, and that actually means exponent. A lot of scientific calculators have a button that looks like that. So I just typed in A, and then I hit shift to the 6th, and it did that. And then, of course, I needed a 6, so same thing on the denominator. And that's how it's done.